Hi all, in this video I'm going to cover tree diagrams, which is like pages 6 through 8 of this lesson. And this is probably something that you've done before in a math class, so this shouldn't be a new concept. So we're going to look at a couple of examples now. A fair coin is flipped 3 times and the result is noted each time. The sample space consists of ordered triples such as heads, heads, tails. Draw a tree diagram to show all of the different outcomes in the sample space. So the key thing is we're flipping the coin 3 times. So on the first flip, we could get heads or tails. Then if we get heads on the first flip, we could get heads or tails on the second flip. Same thing here. If we get tails on the first flip, we could get heads or tails on the second flip. So this is what's happening on the first flip. This is what's happening on the second flip. And now we're going to flip a third time. You could get heads or tails, depending on what came up previously. It doesn't matter what came up previously. So there's your tree diagram. That's what could happen on the first coin flip, second coin flip, third coin flip. Part B says list all the outcomes as ordered triples. How many of them are there? So we're just going to follow the tree diagram heads, heads, heads. So that first ordered triple is just H, H, H. Then I'm going to go down systematically heads, heads, tails. Next, heads, tails, heads. Heads, tails, tails. It makes listing the sample space out much easier because I can see this visually. Tails, heads, heads. Tails, heads, tails. And so on and so forth. Tails, tails, heads. And then the last one, tails, tails, tails. So there's a total of 8. There's 8 possible outcomes. So when we start talking about probability here in part C, it's going to be out of 8. So what's the probability you get all heads? So if we look at these, heads, 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 that's the only one of the 8 where that happens. So 1/8. What's the probability you get exactly 2 heads? So out of 8, this scenario, there's 2 heads. This scenario, there's 2 heads. 1, 2, 1, 1, 0. So 3 divided by 8. What's the probability you get all heads or all tails? So out of the 8, all heads shows up here. All tails shows up here. We want to get all heads or all tails. There's 2 possibilities out of the 8. Okay, let's look at one more question. If we take a look at page number 8, I want to show you question 18. This has got a slight variation to it. Samuel pulls 2 coins out of his pocket randomly. Here's the slight variation without replacement. When we just did the coin question, if you flipped heads first, you could still flip heads on the second one. What's going to be different here is once he picks one coin, he's not going to be able to pick that coin again. So in his pocket, it has 1 nickel, 1 dime, 1 quarter. What's the probability he pulled out more than 20 cents? Justify your work by creating a tree diagram or sample space. So if we think about what could happen first, he reaches into his pocket and he grabs either a nickel, a dime, or a quarter. Now he reaches back in again and he pulls out a second coin. So if he pulls out a nickel first, he can't pick the nickel anymore. So all that's left is the dime and the quarter. If he picked the dime first, all that's left now is the nickel and the quarter. And if he picked the quarter first, all that's left is the nickel and the dime. So that's how this is different. If this was done with replacement, there would be a nickel option here, a dime option in the middle, and a quarter option in the bottom. So you have to think about the scenario when you're going through these tree diagram questions in a minute to see if it's with replacement or without. So now we have to talk about how much money, more than 20 cents. So nickel is 5 cents, dime is 10 cents. So he'd have 15 cents here. Nickel and quarter would be 30 cents. Dime and a nickel, 15. Dime and a quarter, 35. quarter and a nickel, 30, quarter and a dime, 35. So there's a total of 6 outcomes. 1, 2, 3, 4, 5, 6. Out of those 6, we want more than 20 cents. So we're talking 1, 2, 3, 4. 4 of the 6 scenarios resulted in him pulling out more than 20 cents. All right, at this point, what I want you to do is go back to page 6. You're going to be practicing tree diagrams. You're going to finish up page 6. You're going to finish up page 7, and you're going to finish up page 8. So pause the video, go ahead and work through those, and then come on back and I'll go through those. So on page 6, taking a look at the bottom question, number 16, the possibility of having, the possible sexes of having 3 children. So the first child could be male or female, same for the second, same for the third. So the sample space is similar to the coin question in number 15. I just listed it out. There's a total of 8. What's the probability of having all 3 kids of the same sex? You have all 3 male or all 3 female, 2 out of the 8 scenarios. B is a little different. You have 2 different bags you're picking from, a marble from. Bag 1 has 2 green and 1 red. So here's bag 1's pick. And then bag 2, it's 1 orange and 3 purple. So each of these has 1 orange and 3 purple for the second bag pick. So if you list out all the outcomes for the sample space, there's 12. And it just wants to know the total number of outcomes. It could say, what's the probability you pick a purple? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 12. It's not asking that, however. Number 17. You're selecting an outfit at random. You have 3 shirts and 2 pants. So you could select the V-neck with the jeans or khakis, the collared shirt with each, or the t-shirt with each. So you have 6 total outcomes you could select. Flipping a coin 3 times. We already did this. What's the probability of getting all 3 flips the same? That's heads, 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 or tails, tails, tails. 2 divided by 8. C and D both deal with ice cream. So you have 2 scoops, mint, cookie dough, or bubble gum, and then you could get the same second scoop. So there's 9 total outcomes. If you want the same flavor, it could be mint, mint, cookie, cookie, or bubble, bubble. Bubble, bubble. It's fun to say. Bubble, bubble. 3 out of 9. All right. D, you're ordering ice cream. You have now 3 scoops. I didn't draw out the whole tree diagram because there's like 27 options and I didn't really have space. So here's what I did. This would be vanilla, vanilla, and then off of that branch would be vanilla, chocolate, strawberry, and so on and so forth. And then I didn't list out all 27 options. The probability of getting a cone with all scoops being different flavors, so it's vanilla, chocolate, strawberry. That would be 1. Vanilla, strawberry, chocolate is 2. Chocolate, vanilla, strawberry is 3. Chocolate, strawberry, vanilla is 4. Strawberry, vanilla, chocolate. Strawberry, chocolate, vanilla. So there's 6 divided by the 27. So that might have taken up the whole page for y'all. Then looking at the last 2 questions, 19 and 20. Okay, they're talking about these people making dinner and washing the dishes. The first person name drawn is going to make dinner, and the second will do the dishes. So first name is going to make dinner, second do the dishes. So this is like question 18 with Samuel. If Janie gets picked first, then only Tom, John, and Tamara are options. I didn't put in the initials here, or the first couple letters. All right, then if Tom gets picked first, then only Janie, John, and Tamara are options. So it's done without replacement. So you have 12 total options. What's the probability that the 2 people pulled will have first names beginning with the same letter? So JJ, TT, JJ, TT, 4 out of the 12. And then question 20 just goes back to the complement idea. The probability you pick a purple marble is 7 divided by 62. What's the probability it's not purple? So the complement, 1 minus that, 55 divided by 62. So hopefully that was a nice just overview of some things you've seen before in previous math classes. We're going to continue to build off of this as we move further into this unit. And I look forward to working with you. If you have time left in class, you can spend the time using, I can't speak. Spend time on other classes, work that you need to get done, or help out your classmates, please and thanks.